Hi everyone, my name is Ruben Opdebeeck, and today I'll be talking a bit about the pitfalls of Ansible's variables and template expressions. So for those unintroduced to Ansible, it's an infrastructure as code language, and it allows you to quickly set up large and complex digital infrastructures. It offers you three main things. One of them being configuration management that targets a single machine and configures that machine, setting up user accounts, installing packages, managing the configuration of those packages, and the like. Now, if you pair that part up with the multi-machine deployments, you can quickly set up a whole range of machines in an infrastructure. You can give Ansible a list of 50 IP addresses, and Ansible will happily configure all of them according to your configuration definitions. And then finally, you can also do a bit of cloud provisioning with Ansible, things like starting and stopping Amazon EC2 instances and some other things. So because of this versatility, Ansible is quite a popular language. If you look at the Stack Overflow developer survey of this year and you compare Ansible to some of the other infrastructure as code tools, it's doing quite well for itself there. If you specifically ask infrastructure developers which sort of tools that they use, Ansible is coming up as an answer quite often as well. So because of this popularity, there's been quite a bit of academic research on Ansible. I've been involved in some of that research. I've mainly been working on static analysis of Ansible code recently. And while I'm doing that research, I bumped into a couple of, let's say, peculiar things that Ansible is doing with its semantics that I really wanted to talk about today. So I'm not going to be talking about that configuration management or the multi-machine deployments or even the cloud provisioning parts of Ansible. I really want to talk about the language itself. So let's look at that language for a bit. Let's get some of the basic terminology out of the way. In front of you, you can see a playbook, and this playbook is really the main file of Ansible. This is the file that Ansible will load, and that tells Ansible what it really needs to do in order to configure all of these machines. Now, a playbook consists of a play, or at least one play. It can be multiple as well, and each play targets a group of machines. So in our case, our hosts that are going to be targeted is called databases. Let's assume it's a list of IP addresses somewhere that describes all of our database machines in our infrastructure. And that play will then configure each and every one of these machines individually. It does that through tasks, and these tasks are the basic building blocks in your play. That's each of them is a single step that the play will undertake to configure each machine. Now, a task executes exactly one action. In the first case, the action is going to be opt. In the second case, the action is going to be copy. And you can also provide some arguments to those actions, like for example, for opt, we can give a name, PostgreSQL, and a state of present. And what this is really doing is it's telling the opt action, hey opt, can you make sure that the package with the name PostgreSQL is present on the system? If it's already installed, opt isn't going to do anything, but if it's not installed yet, opt will actually install PostgreSQL. Similarly, for this copy action, what we're really saying is, hey, can you check this destination file and make sure that it has the same content as the source file? If it doesn't exist yet or the content differs, the file will be copied over. On the other hand, if everything is fine, nothing will be done by copy. So really, if we would execute this play, what we would do is install PostgreSQL and configure PostgreSQL on each of these machines in this database group. But what we're really still missing from this playbook is things like variables and expressions in order to make it a real programming language, right? And Ansible does offer you variables and expressions, but the semantics of them can be quite weird sometimes, a bit unconventional at times. So because we're going to be talking about unconventional things, I'm going to be using an unconventional presentation style. I'm going to show you a couple of examples. I'm going to briefly explain some of these examples, and I'm going to pose a seemingly simple question, and then I'm going to display a couple of multiple choice answers. And of course, this is pre-recorded, so I can't do a show of hands of who thinks it's going to be answer number A. So you'll have to sort of choose in front of your computer and then hopefully get to the right answer afterwards, right? But let's see how it goes. So for this very first example, we're defining a very simple play. Now this play defines one single play variable. named A, and that variable will be in the scope of the play, but of course not in any other play. So it's scoped locally to the play. Now A is sort of initialized with an expression, which is a Jinja2 template expression, and that expression is actually just a string, but everything between these double braces will be evaluated and substituted when it's handled by the Jinja2 templating engine. So the question here is quite simple. What's the value of A going to be? Is it going to be 3? Is it going to be 1 plus 2? Or is it going to be neither? So in order to figure that out, we have to, when this expression is evaluated, we'll have to actually evaluate this 1 plus 1 between the double braces. That of course is going to lead to 2, no surprises there. And then that 2 is going to be substituted back into this string. So we get 1 plus 2. But note that I said when this expression is evaluated, because I can actually change this playbook to introduce a 0 division error in an expression, I can execute this playbook and it's not going to crash or anything. And that's because all of these expressions are lazily evaluated. And they're not just lazily evaluated, they're actually re-evaluated every single time that they're used. But because we're not using A, we don't ever have to know what the value of the expression is going to be, and it's never going to be evaluated. So actually, A is not a name for a value, A is a name for an expression. So the value of A doesn't really exist, and the correct answer in this case would be C. Now there are a couple of exceptions to that rule. We're going to be seeing one of them very shortly, but for the most part you can assume that a variable is a name for an expression, not a value, and an expression will be reevaluated every single time that you're using them. Now just to drive this point home, if we actually consume A in this debug task, which will print a message to the screen, we have this expression that dereferences A. In order to print the message, we have to evaluate this expression, so we have to evaluate whatever is bound to A, which is this expression, and of course we get this 1 plus 2 as we've seen previously. But let's see how this can actually go wrong in plausible real-world code. Now this is still a fabricated example, but this is code that you might see in the wild. So the basic premise of this play is that we have to install two different configuration files. We have a config.ini and a companion.ini. Both of these need to be present at the same time on the machine. All right. So we're defining a play variable named file exists, which is initialized sort of with an expression config.ini is file. This is a Jinja2 test expression, which checks the path here on the file system and checks whether it is a file or not. And then we have two tasks, one to copy over the configuration file and then one to copy over the companion file. And both of these tasks are conditionally executed using this Jinja2 expression. This is still a Jinja2 expression, but we're not using the double braces. There's a technical reason why you don't have to use double braces, and you shouldn't use double braces actually, but I'm not going to go into that today. So what would happen at runtime here? Let's assume that config.ini doesn't exist yet, right? The first thing we do is we evaluate this conditional. Right, but at this point config.ini doesn't exist, so this conditional will, like this expression will return false. We're inverting that to become true, and then of course this task will be executed. This task then creates that config.ini file, copies it over from this base configuration file, right? Then we move on to the second task, but this whole thing will be reevaluated. So this expression, the value isn't remembered by this variable, right? So this whole expression is going to be reevaluated, and we've just created a config.ini file. So this all of a sudden starts to return true. So this gets inverted, and actually the whole task gets skipped, and we're never creating the companion file. And you can never create a companion file using this method because you're always going to create a configuration file first. So this playbook is completely broken. Now, what can we do to fix this? Well, for this specific example, we shouldn't actually use these conditional executions because we can just rely on copy not doing anything when everything is already correct. But in general, if you have a variable that needs to sort of remember its value, you can use setFact, which is one of the exceptions to the rule of variables are names for expressions that I said earlier. So setFact really takes an expression, greedily evaluates that, and then binds a variable to the result of that expression. And that value is not going to change anymore. Right. So let's move on to the second example, where we're going to be looking into variable precedence. So again, we have a fairly simple play here. Here we're defining again a play variable named a, initialized to 1, and we're also defining a task variable, again named a, initialized to 2. Now this a and this a, they're different variables. This second binding of a doesn't change the previous binding, it just introduces a new one in a different scope. So this is only present, this a2 is only going to be available in the scope of this single task, right? The question now is, when we evaluate this expression to print a message which dereferences a, which a is going to be used? Is it going to be the play variable or the task variable? Is it going to print 1 or 2? Now you'll be pleased to know that it's actually 2, because of course this is a more specific scope, so it overrides the variables from a less specific scope. A bound to 2 takes precedence over the a bound to 1 in this case. And this is what I think most of you would expect to happen. But let's look at the third example, a second example of the variable precedence actually, where we're using some other means of defining variables. So again, we have a very similar playbook here to what we've seen in the previous slide, but we're now using an include vars action. So this is a separate task that executes before this debug task that includes variables from another file. Now this other file is presented here, and this defines a to the value 3. Now, when this thing is executed, this a is going to be included into that play in a global scope. So it's going to be available throughout the whole play. But of course, variable precedence comes in there, and the question then becomes, this a, what is it going to resolve to? The play variable, the task variable, or the included variable, right? So we have 3 different options. Either it's going to print 1, 2, or 3. Now, in order to figure out what it will actually print and what this a will actually resolve to, we have to check the precedence rules, and they're quite long. There's 22 different precedence rules. I've shown you, I'm showing you all of them right now. You don't have to, please don't try to read all of these. But the main takeaway that you can find here is that we're going from lower to higher precedence. And one of the more low precedence variables are these play variables, right? And then you have the task variables that are at higher precedence. So that's basically just confirming what we've seen in the previous example, that task variables take precedence over the play variables. But we can also see that included variables take precedence over task variables, which is quite surprising because included variables are both globally visible, but then they also override locally scoped variables, right? So they're globally visible variables that take precedence over locally scoped variables, which is quite a surprising result. I mean, I do not know of any other language that allows you to define a global variable that takes precedence over a local variable, but apparently that is possible in Ansible. So when we look back at this example and we trace the precedence of this variable a, we can see, okay, in the first case, a bound to 1, the play variable, is going to win when this gets defined because, of course, there's no other copy of a. But then we execute this include vars action, and a3 is being put into the global scope, but takes precedence over most other variables. So now the a bound to 3 is going to take precedence. Now, when we actually execute this debug task, the task variable, where a is bound to 2, is useless. It can never be used anymore because a3, included from this myvars file, is going to take precedence anyway. So you can never use a bound to 2, and this a here in the expression is always going to resolve to a3 in this case. So it will actually print 3, which is quite a surprising result in my opinion. Okay, let's move on to the fourth example. So we've seen expressions and we've seen variable precedence. Let's take both of them together now. We again have quite a similar playbook. We're defining a at the play level being bound to 1, a at the task level being bound to 2, and a at an included variable level being bound to 3. But now we're also defining a b at the play level, where the expression here is a plus 1, and that B is going to be printed by this debug task. So what will actually be printed? Will this B, when evaluated, so then we're evaluating this expression, will this A then resolve to the play variable, to the task variable, or to the included variable? Now, it really depends on whether or not this expression closes over the scope in which it's being defined, because if it does close over the scope, then you could say, well, then A is referring to this A in the play variable scope, but unfortunately, it doesn't close over its scope. So this expression is not a closure, right? So what really happens here is that, okay, you're evaluating B, so then you have to evaluate A plus 1, but A plus 1 will be evaluated as if it were written here, in which case A will resolve to this included variable, and it doesn't really matter that it's defined at the play level, it's just going to use whatever is the highest precedence variable at that point. So you're going to evaluate 3 plus 1, which becomes 4, and this thing will actually print 4. And that might get a bit surprising if you have complex configuration files and complex playbooks where you have multiple variables, you're using a bunch of expressions, and then somewhere you're doing an include var statement, and 200 lines down you're using a variable that's defined by an expression where the expression uses a variable that's overridden by the include variable statement, and all of a sudden it changes value. If that happens, well, it's going to be a bit tough to debug that. Let's see how that can actually happen with something called roles. Now, roles are, I'm not going to go too much into depth of what roles actually are, but you can consider them a bit like the libraries of Ansible. They're kind of modular playbooks that can be distributed to third parties. There's a whole bunch of roles on GitHub, and there's a platform called Ansible Galaxy, which is kind of Ansible's NPM, right? So these roles are really like the libraries that are focused specifically on doing one thing. And we might have a role that installs and configures, for example, Nginx, which we're defining right here. Now, a very common pattern that you'll see in these roles is that they try to support multiple operating systems. And if you're installing configuration files or something, for example, oftentimes on different platforms, those configuration files are going to be installed in a different directory. So for Nginx, for example, in Debian, you're installing that under etc/nginx, but for another operating system, that might be a completely different path. So something that a lot of these roles are doing is, as one of the very first tasks that they execute, they use include vars to dispatch based on the operating system. So this would load a file called, if it were executed on Debian, it would load a file called debian.yaml, which would be this one, and which would define, for example, a variable config path to be that path. And then the whole configuration thing is copied over into that configuration path. This role works as intended. But as I said, it's a very common pattern to use these things, these include vars statements in these roles. We checked a data set of about 26,000 of those roles, and we found about 1 in 5 of those roles actually used include variables. So that's more than 5,000. I think it was actually closer to, well, I can't remember exactly, but it was 1 in 5 nearly. So let's say we're including this role into one of our playbooks. Now we have a playbook that's supposed to install PostgreSQL and also configure PostgreSQL. And in this playbook, we define a play variable named config path. The configuration path points to the configuration directory of PostgreSQL. But we're also including this Nginx role, and that Nginx role will also include its own variables that also defines its own configuration path for Nginx. So let's see what happens actually. So here we execute a play, we define this config path variable which points to the PostgreSQL path, which at that point takes precedence. But then we include the role, which in turn includes the variables, in which case then you get this config path variable that's taking precedence here, that's pointing to etc/nginx, the nginx directory, right? Then you're copying over this configuration path in the role exits, you get control back in your playbook, but this config path thing is still global and still takes precedence. So when you're trying to copy your PostgreSQL configuration path, config path here will actually point to the etc/nginx directory, and you're all of a sudden installing your PostgreSQL configuration in the etc/nginx directory in the nginx configuration directory, which is completely wrong. And if this actually happens, I mean, these are contrived examples, but roles tend to get very large, especially for things like Nginx. Playbooks for things like PostgreSQL get very large as well. I mean, debugging this is not going to be easy. And this is also not the only thing that can happen. In this case, a role is overriding your variables, but you could accidentally override the role's variables. Two different roles might accidentally override each other's variables. A lot of different things can happen. Just imagine this if this were to happen in a language like Python, where you're writing a program that counts the number of lines in a text file. You have to import a mathematical library. You have your own function called countLines, but the mathematical library also defines a function called countLines, which counts the number of lines in a polygon, for example. And because you've imported that library, your function is swapped out for the library's function, and then when you're trying to count the number of lines in a text file, it will actually try to count the number of lines in a polygon. If that were to happen, people would really be confused in Python, but it is a reality in Ansible that these sorts of things can take place. Now, what can you do to fix this? Well, there's not really much of an option. The main thing you can do is maybe rename these variables, qualify them with your role name, for example, or something else. So instead of using config path here, you might be using nginx config path. Most of the roles do this. They prefix their variable names, make it fully qualified to hopefully make them unique enough that they don't conflict with any other variables in those playbooks, right? But so, like I said, I mean, if this were to happen, it would be quite difficult to debug. So what can we do about this? And with we, I really mean the researchers in the audience today. I'm assuming that there's going to be researchers in the audience. I don't know, I'm pre-recording this 2 weeks in advance, but let's hope that there are at least. So at least the first thing we should do is spread awareness about this. And that's what I've been trying to do today, talking about these sorts of things. And hopefully this presentation reaches at least one person that's going to look at this and is going to say, hey, wait a minute, maybe I'm doing this in my playbooks. Maybe I should check that I'm not accidentally doing something wrong here. I haven't accidentally introduced a bug because I'm not properly understanding some of Ansible's semantics. If we can do that, that would be great. But I don't think that's going to be enough. Because it's so easy to actually introduce these bugs and so difficult to properly debug them, I think we should research some bug detectors or static analyses to at least either warn about possible defects related to these semantics or make sure that they don't really happen. So I'm personally a static analysis person. I've been working on static analysis related to some of the data flow of Ansible. I can tell you that it's not as easy as it should be, or at least, I mean, data flow analyses in languages like Java are pretty well understood, but for Ansible, because you've got these unconventional semantics, it's a bit trickier, right? But at least we should put some effort towards researching those types of bug detectors. And then we should actually also investigate the impact of these semantics, because I find it personally very hard to believe that such semantics haven't ever led to real bugs in code, right? I mean, like I said, you can imagine if your playbooks get very complex, you could all of a sudden accidentally start changing a variable that might have effects in a completely different source file that you might not actually foresee yourself. It's really difficult to detect this manually. Even automatically is really difficult to detect that. So does that actually happen? And do these bugs, are they caused by some of these weird semantics? And if they are, then we should propose solutions to those bugs. We should look into making Ansible a safer language in regards to that. Or we might look into alternatives. We might say, okay, this actually also happens in another infrastructure as code language. What can we do there? So I think we as researchers should put some efforts forth to make infrastructure as code languages and Ansible a safer language for use, because it's really popular and it's not going to go anywhere, right? So in conclusion, What I've mainly shown you today is that variable precedence in Ansible can be quite complicated and that their expression evaluation semantics sometimes is a bit exotic. Now, if you take these two things together, you get a situation where it's very easy to accidentally introduce bugs, but very difficult to properly debug where it's actually happening. So there's a lot of directions for future work here. As I just mentioned, we can do static analyses, we can make bug detectors, but we should study the impact through empirical studies. We should investigate whether we can improve the language design of Ansible or the language design of other languages. So I think we as researchers can really find something that's worth doing and improving the state of the practice in infrastructure as code today. With all of that said, thank you very much for sticking to the end of this video. Like I said, I hope at least one person saw this and said, okay, oops, I made a bug in my program, and let's make the infrastructure as code domain a better place. Thank you very much, and goodbye.